Hi folks, so the next thing up here is a Marantz 2270 receiver. I've got this from another friend of mine. This one doesn't belong to Steve, surprisingly enough. And it's not coming out of protection. There's a problem with it. I checked, got the cover off. There's no loose wires, nothing unattached anywhere that could cause problems. So we'll fire it up in the dim bulb tester and see what kind of issues this thing has. So I have it on the dim bulb tester with a 100-watt lamp in there, and I'm going to turn it on, and the bulb acts normally. But we do not hear the relay clicking. All right, I'm going to post a bit of the schematic up here because the output stages on this are a little different, and it's going to necessitate a different approach to see if there's any problems in the outputs. All right, if we look at the schematic here, both output stages are identical as far as notation goes. They're two separate modules. You can see we have our output transistors at H003 and H004. And the emitter resistors don't tie together as they do in most amplifiers. What they've done here is they're actually picking the signal off the collectors. And if you trace here from H003, you can see that it goes to the output, and the collector of H004 ties to H003. So that makes life a little easier because all we have to do is go to the collector or the can of each of one side of the outputs. So if you look here, and I have a different meter up here. I think it's going to be a little easier to see. If we go to the collector here, we got about 0.35 volts. That's a fair amount of offset, but it's not going to throw the amplifier into protection. However, if we take a look at the other channel, we got 38 volts of offset. So we have a problem in this channel, and the first thing, of course, I'm going to check is the outputs. All right, so I've got it standing on its side so I can get to both transistors here, and I don't know which terminals are which, so I'm just going to poke all three of them while referencing the collector. All right, so I put one lead on the collector, and I go underneath, and although you can't see the meter, you'll be able to hear it. That indicates short. One of them will, because one of them is the collector. Again, I don't know which is which. But all three are indicating shorts. We'll know more about what's actually going on after I remove them. But just to check them in place, this is the easiest way to do it. So I'm going to pull these out and we'll check them. And I want to talk a little bit about shorted outputs. It's really common and probably the most common cause of amplifiers stuck in protection. There's a lot of reasons for this. These things are getting older. You run them hard. You run them into difficult loads. Transistors, the outputs will overheat, short out. Short your speaker wires together, they'll blow in a heartbeat. There's a lot of reasons this is what we find, but it is most commonly what we find. And if you've watched this channel for any length of time, you will have heard me say, let the symptom be your guide. What I mean by that is, what's the symptom? In this case, it wouldn't come out of protection. And therefore, we want to take a look at the outputs to see why. Because the protection circuit monitors the DC voltage on the outputs. It should ideally be 0. You should have no offset. A little is not going to trigger it, but you got a couple volts and it's going to trigger the amplifier to go into protection. It'll open the protection relay to protect your speakers. And when I say let the symptom be your guide, if you're having trouble with the air conditioning in your car, you're not going to be on all fours in the driveway looking up the tailpipe. You're going to be under the hood. You're going to be looking to see if the clutch is pulled in on your compressor. You're going to see if you have gauges, if you have Freon. If the fan's not blowing, you're going to take a look at the blower motor. this is what I mean by let the symptom be your guide. And if you're new, you won't understand this, but there are so many great resources on the internet, so many great sources on YouTube to help you gain an understanding of how to troubleshoot and how to troubleshoot stereos or audio or electronics in general. And you need to have at least an idea of what you're looking for and looking at. So anyhow, I'm going to pull these transistors and we'll check them and see what we got going on here. All right, I've got both transistors pulled out. This one is the PNP. This one is the NPN. So, red lead to base. Remember, TO3 package leads closer to one end than the other. That makes this the emitter, this the base. We go here, so we go base to emitter. That's open, and that should not be open. We go base to collector. We have a dead short. Go emitter to collector. We have nothing. So we have a base to collector short right there. So this transistor is bad. This is our PNP. Japanese transistors are so easy. If you have 2SA, 2SB, it's PNP. 2SC, 2SD is NPN. So if it's A or B, it's PNP. Kind of how I had to remember it. But anyway, we put the black lead on the base on this. We have a dead short base to emitter. Dead short base to collector. Dead short collector to emitter. Both outputs are bad. Now, before we just pop new outputs in, we need to check back before there to make sure there's no collateral damage. I always go from the output back. Generally, this is where the failure occurs, and the failures can cascade back through the amplifier. I went back and checked, and there's nothing that's directly in line here that looks like it was damaged. If you look here, these are our emitter resistors. They both check good. They were easily checked by checking at the terminals at the end of the board, J753, J754, J760, J761. I also checked the drivers here. They were also good. I circle in red any bad components. I circle in green any good components. So we look good back here. I'm going to replace the outputs, but before I put them in, I want to show you what good transistors look like when you test them. All right, so I'm going to replace those transistors with the onsemi MJ21193 and 94. The 93s are PNPs, and again, it's kind of a rhyme thing to help me remember them. So this is our NPN. So we're going to take a red lead and put it on the base. Remember, these TO3 packages have these leads closer to one side than the other, so we are emitter base in the case of the collector. Red lead to the base, black lead to the emitter, good diode junction. Red lead to the base, black lead to the collector, good diode junction. Emitter to collector, no short, that's good. If we reverse them, we shouldn't get anything, because remember, these are like diodes and they will be reversed. So that's a good transistor. That was me doing this. Our PNP. We have to reverse our leads and put the black lead on the base. Red lead on the emitter. Good diode junction. Black lead on the base, red lead on the collector. Good diode junction. Emitter to collector. Good. Reverse our leads, and these should all read open. Base to emitter, good. Base to collector, good. Emitter to collector, good. These are good transistors. That's how you test them. If we look at our bad one, I'm just going to grab one. This is our PNP. Shorted, shorted, shorted emitter to base, shorted base to collector, shorted emitter to collector. Our NPN, red lead to the base, black lead to the emitter, that junction is open because it should check just like this one. Red lead to the base, black lead to the collector, shorted. Emitter to collector, open. So we have a base to collector short. It shouldn't do that. It should look like this. If we reverse it, we're still going to have a short. Black lead to the base. Remember, this is a NPN transistor. Shorted. So that's how you test these transistors. In fact, that's how you test all transistors. I just wanted to give a little better overview of that. So I'm going to replace these transistors. And by the way, I ordered these TO3 micas by the 100. And I want to show you something I discovered about Mouser that makes ordering this stuff a lot easier. All right, this is Mouser's website, and I'm going to take and put the carrot right up here. And this is an off-the-shelf USB barcode scanner. You have to kind of make sure. There. And here are our micas. I usually get them by the 100, cost me 12 bucks. And that's an easy way to reorder parts from Mouser. As you can see, I had to black out these two because this barcode scanner will scan any of these, but the Mouser part number is really the one you want. Once I got that, I was able to get right back to the page I ordered these from. So I'm getting a little low. Next parts order from Mouser. I'm going to put 100 of these in the basket. I pretty much buy any fairly inexpensive parts by the 100. That saved me a lot of times because these parts tend to go obsolete fairly often. So I'm going to put these output transistors in. We'll see if we can get this thing out of protection. I just wanted to show you that while I was thinking about it. After replacing outputs, it's mandatory that you check the bias. Now, if we look at step 3, that's our idle current, and that's what bias is. Bias is quiescent or idling current, kind of like setting the idle on your carburetor. Back when we used to have carburetors, if you're under 50, you probably don't know what the hell I'm talking about. Anyway, they want us to measure between pin terminals J753 and J754. And that takes us across one of the emitter resistors. Now I'll show you that before we attempt the adjustment. And I want us to set it for 5 millivolts. And I'll show you what the math works out to for that. I think it's around 25 milliamps of current flowing. But anyway, I've got a meter connected, and we're going to take a look at that. I've still got it on the dim bulb, but to get an accurate setting, we'll have to take it off the dim bulb tester and let it warm up. But I wanted to talk about this procedure. Now, the adjustment they want us to turn is R763. They want it fully counterclockwise when we start and rotate it clockwise until the VTM reads 5 millivolts. And if we look here, this is the board layout, and R763 is the one closest to one of the drivers. So that makes it easy to orient on the board and find out where it is. Wow, we got some issues here. I'm going to turn the camera off while I figure this out. It was a bit of a bear to get out, but this is the bias spot, and I pulled the Simpson out so you can see the meter movement. And as I turn this, it goes up, and then it goes back down. All right, so if I turn it clockwise, it goes up to a certain point, and then it goes back down. We have a bad bias pot. I'm going to see if I have anything that I can use in here. I have some, but the orientations may be wrong. This one, as you can see, has the legs on the bottom and the adjustment out front, and I don't think I have anything like that. But I'll take a look, see what I have, because this has to be replaced. This is a 1K. Okay, so I've got the adjustment pot here replaced. It's a different style, but that's fine. So I'm going to turn this on. You'll hear it click out of protection. Okay, it's really a soft click. But anyway, here's our pot. And you'll see why people like to use multi-turn pots, because boy is this touchy. Oh, yep. We want 5 millivolts after it warms up, so we really want just a little less now. It's hard to get. It's really hard to get. And I can see, like I said, why people like to use these multi-turn pots, because look at what we have going on here. This is just nuts. And it's brand new pot, but I did scrub it a few times. Okay, I'm going to leave it there. There may be some other problems in here, but we have some kind of bias. So I'm going to hook up the test equipment to see if we can get signal out of this thing. All right, so let's feed some signal in. And we have signal on both channels. About 10 watts. Okay, that's about max there. 65 watts. This is a 2270, so it's 70 watts a channel. And it's exceeding that. We got 78, 80 watts. Distortion is a little high, but I'm mostly concerned. Let's get the level set right. And I'll switch these cables out for ones that are more accurate for distortion. But there, 0.04, 0.03, about 70 watts. So everything's working now. I got to pull the front off and see what's going on with that monitor switch. Oh boy. Okay, so in order to get these switches out so I could get that tape monitor switch, I had to take out the function selector, I had to take out the microphone and headphone jack, I had to loosen the front so I could move it a little bit so I could get the function switch out. And then I had to take the screws out for this and kind of work this out and then turn the tabs. If you look here, you see how these tabs hold this down? I had to turn these tabs up to get the switch out from the donor board. And now I'm going to have to solder each one of these wires onto the new one. I guess the retaining clip or whatever holds this in the back came out, and this should go in like this. Anyway, this switch is broken and I'm going to have to replace it. So, oh yeah, and I had to pull out the switch, the tone board too. I'm going to take a look at that, see if there's any capacitors that need to be replaced while I'm in here. Doesn't look like it. Looks like it's just a passive board, but I will clean out all the tone pots while I'm in here. But yeah, this is, I had to do the same thing on the 2225. This is not my favorite thing to have to do. This one doesn't have a printed circuit board though, like the later ones do, which makes life a whole lot easier. So I got to do this wire by wire. Well, I was listening to the radio on this thing and everything was sounding good. I had set the bias and offset both channels. Everything looked happy. I was happy. Happiness is a very fleeting thing because as I was listening, it clicked into protection and never clicked out. So I did a quick check and the collectors, which remember are tied to the outputs, on this side I got a negative 37 volts. That's not good. If you recall, we had problems on this channel. I replaced the outputs and I had that sinking feeling that the outputs had shorted again, but they check good. So I'm going to have to go back further and see what's going on. All right, so I was working on this. The voltage is straightened out and it came out of protection. But every once in a while, and I found a blown fuse on one of my speakers, the left channel, what we were working on, has an incredibly loud pop. Now I'm just going to let this go and I'll edit out the dead air, but this thing pops loud. I didn't get to record the extremely loud crack that this thing makes, but I'm going to replace the differential pair in the front end, and I'm not sure if it's current mirror that's coming off of it, but in any event, there's 3 small signal transistors. Small signal transistors will make noise, but it's usually like a crackling or hissing. This sharp crack by itself is not something I've heard, but generally speaking, this is where your noise sources come from. It's going to be a bit of a bear to get these boards out. I did work on this when I replaced the one adjustment for the bias, but I'm going to have to take it apart again and see what's going on here. I believe that's where the problem is coming from with direct coupled negative feedback amps. It's really hard to tell. Plus, it happens so infrequently that I think this is the best course of action for now. And then I'm going to have to leave it on for a while and see if it does it again. In order to gain access to the transistors I need to pull from this board on the left here, you want to primarily first pull the clip that holds the thermal tracking diode and bias transistor onto the heatsink. You don't want to break these things. I don't think these are too hard to find, but I don't want to find out. So pull that one first. Always try to remember to do that because there's usually some kind of thermal tracking device attached to the heatsink that you don't want to break. So take this screw out first. I pull the 4 screws from the printed circuit board, and then 4 screws that hold down the heatsink assembly, and then we get what you see here. I'm able to access the back of the board here to get to the transistors I need to unsolder. Fortunately, they use flying leads to get the output transistors connected to the driver board here. So I'm able to, I can leave those in. I don't have to pull them out yet again because remember I had to pull these out to test them because I thought they had blown. They're okay. So I'm going to change out the differential transistors and the basically H751, 752, and H753. Going to change out these little guys and see if that cures the problem. I'm going to leave it on for probably several hours to make sure the problem doesn't recur. I pulled out the differential pair, and I don't always see this on Marantz, but they have them heat shrink together. So I'm going to take a pair, do the same thing. They got the center collector leads insulated, and we'll just grab those and put them on the new pair. Just put them face to face. You can even dab a little heat sink compound between them and then heat shrink them together. So I'm going to do that. You need to use matched transistors when making up these differential pairs. And I ordered them by the 100 on these ammo strips so I can use whatever I'm using to check the HFE, and I can write the results down on the ammo strip itself. So it makes it easier to find a matched pair. You have to go through a fair amount, and if you have readings left over like I do here, you need to check them again because these are very temperature dependent. And that's another reason to get them on this ammo strip, because even the heat from your fingers from handling them can affect the results you get with the meter. So when you have something like this, you can just connect the leads, don't touch the body, and then write the results on the ammo strip. I have the insulated leads pulled off the old transistors, put on the new ones. I'm going to put a little dab of heatsink compound on here. Always keep a rag handy whenever you even look at this stuff because it gets everywhere. I think I've mentioned this is the kind of stuff you handle where you wash your hands before you go to the bathroom. So I'm just going to put a little dab on here. I may be a bit shaky. It's early morning. I've had my first strong cup of coffee, so. All right, and then we got to put the other ones so they are face to face, like so. And then we're going to put our heat shrink on here. Okay, that piece of heat shrink was okay. I just couldn't see. I've really got to get these cataracts addressed. So I use my hot air station to shrink the heat shrink. It's really handy, especially if you have something installed. And just want to do this without burning the crap out of myself. Okay, that looks pretty good. Okay, so we have them heat shrunk together. Let's clean this off a little bit. And of course the insulated leads fell off, but I'll find those and we can solder this back in and change out the other transistor. I have the replacement differential pair put together. Of course, I'd lost the original leg insulators because as soon as you go like this, they're gone. And it's really important to have a carpet in front of your bench in case you drop screws. Because if you drop them on the bare concrete, if you're working in your garage, they will bounce, usually under your bench, never to be seen again. However, this carpet was given to me. As you can see, it has flex in it. So as soon as you drop something on it, it kind of disappears. It just camouflages itself into the flex. But anyway, usually I can find screws and things like that by running my hands over it. Little stuff like that, the vacuum will get it. So anyhow, this is ready to be installed. We have them thermally coupled together. We match them with a meter. So this should be a good replacement. I'm going to do the other channel too, because if these are the cause, the other channel is probably not far behind it. All right, so I ran this thing overnight and it was still fine the next morning. And I've got good output on both channels, distortion's low. So I think we're going to call this one fixed. As always, I thank everyone for watching, and I enjoy giving back to the community that's given me so much. Thanks a lot, folks.